Hey guys, I've spent a lot of time thinking about my blades and how to make them. I'd like to have more freedom to try different bevel angles. The way I do it now, with this clamp, limits what angle I can do. I'm not sure if I like the current bevel angle, but more importantly, I want another way to adjust the weight distribution. Some people have suggested adding fullers. I'm not sure if I can make this look cool, and I don't think it'll affect the weight much. Skeletonizing the blade is another option. I'm not a big fan of this look either, and I'm not sure if this would have a negative effect on their use as scissors. I could do pockets instead of holes, but I think that looks even less elegant. More bevel also means more of a taper to the blade, further reducing the chance of it touching the inside of the handles. So, I think doing a full bevel is worth trying at least once. But, there's another problem with trying to machine bigger bevels. Right now, I'm cutting them with a 3D surfacing toolpath. It's kinda slow, and it gets slower with bigger bevels. So, I started thinking about doing the bevels with the blades on their side. Then, I could use a regular end mill to cut the bevel. But the problem with this is more complex fixturing. I could spend a lot of time making blocks with weird angled faces and holes. Then, if I don't like that bevel angle, I'd have to make a whole new block. So, I thought about using square blocks with tapered end mills. I could start with maybe 5 degrees, and if I didn't like it, I'd have quite a few choices. But it's still another operation and fixture and pricey end mills. I was feeling unsure what to do, but then I saw a post from Aaron Gobe machining a bevel after hardening. Now it's inspired me to try hard milling again. It's back to surfacing, but his speeds and feeds in hard steel made me think it'd be quicker than I thought. It might not be the fastest method in the machine, but maybe I could save a lot of time from handwork outside of the machine. I was unsure of how I was going to get rid of the scale on my blades, and I wasn't sure if it was going to affect my tolerances, or if heat treating already was. Hard milling could be the solution to all of that. I tried to design as simple a fixture as possible to test it. I've been wanting to try using these shoulder screws. They have this round section with a precise diameter. I'm hoping by using them, I can eliminate having to use both dowels and screws. I decided to start with a test in mild steel to see if everything would work. I mill out precise holes for the shoulder screws. Doing the first stop in the vise like this is a little chattery. I check the fit of the screws. Adjust. Good. Here's the fixture I came up with. A block with some holes. I decided to try using 2-inch wide material to be more material efficient. I'll rough out most of the outside area when it's soft, which might be better to do after heat treat, but this felt safer and I wasn't sure. I use a smaller end mill to finish roughing the outside, but that still leaves some slotting. Slotting makes me nervous. I try to avoid it, but for some reason I'm about to do it in hardened steel. This is where I would then stick it in the oven, but not yet. This is mild steel. For this test, I'm going to continue to the part where I finish the bevels. I use the exact same end mill and recipe as Go. It's looking good so far. Next is the slotting. To help with my discomfort with the slotting, I decided to use another feed mill, a tiny one. How is this supposed to ease my fears again? I switched back to the 1/8-inch normal end mill for the last finishing pass. The tabs are still holding everything together, so I thought I could do a finishing pass around the whole thing. But it starts lifting and I nearly have a crash. I do a finishing pass on the backside too, trying to keep the same tabs. It's all really slow feed rates that I'll use for the hardened steel. But I get through it and I unscrew it from the machine. Sorry for the bad view. I was a little excited to check it out and break them apart. Here they are. I think I do like the look a lot. The tool marks might make it look rough, but it's very smooth. And even a little reflective. Let's try the blade steel now. I added more threaded holes so I can stop the blade from lifting. And I decided to only do the shoulder screws in the vise and try to do everything else on the fixture. It's not a big deal to do the rest on the fixture, so I don't have to worry about bend or chatter. Or is it? Did my drill just hit the screw? Then I realized I can't use the same holes. I added a second fixture so you can see. Even if I rotate it, it doesn't work. So I need more holes. This fixture keeps getting more complicated. Okay, now I have to pay attention to which way I put it on. Luckily, the carbide spot drill handled that screw like a champ. Now I can do all the holes and pockets while on the fixture. It looks nice. I then rough out everything. I don't know if Go roughed out his bevels before heat treating or not, but I thought roughing beforehand is faster. And now I can wrap it up again. It helps if you fold it before putting the blade in. I tried using large pliers, but the jaws aren't totally straight, so they weren't super helpful. I think I did a better job this time though. And I only need to wrap one thing now. This time, I decided to put them in after the oven reached 1600 degrees. Everything else was the same as last time. Quench, temper at 600 and cool twice. Looks pretty cool. The screws for the next operation still fit. I was a little worried. I was ready to desperately try to hand ream them. But how hard are they? 60 scratches, but it doesn't seem like 55 is, so I think it's the same as last time. Which maybe is good. Looking at this chart, maybe I'll have to temper at a lower temperature if I want it harder. Okay, time for the scary part. Let's see if we can actually hard mill the bevels. It seems great. I switched to air instead of coolant. Apparently you want air for hard milling for some reason. I don't know why, but it seems good so far. Now it's time for the even scarier task of using tiny tools to bring the holes to size. I started with the 3/32 inch end mill to get the center holes to size. Then it was time for the 16th inch end mill. You can see it removed the discoloration even with a very tiny cut. Was that the scariest part? Because now I have to do the slots. I screwed it down this time. And the feed mill seemed pretty good. The 1/8 inch, however, was ridiculously slow. The chart I was looking at recommended a feed rate of 1.8 inches a minute, I got impatient and sped it up a little. The slots could have gone better. The sounds it made when going up and down the tabs did not sound too good. It's definitely more brittle now, but I got them done, and once again I excitedly broke them apart. They came out awesome. Look at how shiny they are. It's hard to get across. Some angles it might look rough, but it's super smooth, almost like a mirror. You can see how much more reflective it is than the soft steel one. This is one of the coolest things I've done. There's a little ugliness here. That's from the stock being too thick. It isn't there on the test blades, made of the correct thickness of stock. I still need a grinder or something. The spine is pretty bad though. Turns out the last bit of slotting went worse than I thought it did. Maybe I shouldn't do blades in pairs like this. Oh, and let's not forget the weight. Here's the old design of blade, compared to the full bevel. Maybe it's not a huge difference, 16 grams, but if my scissors are around 150 grams, then losing 15 grams would be losing 10%. That sounds more significant. I don't know, I'll mess with it more when I've made more of the other parts. It didn't go perfect, but I think this hard milling method has promise. It's at least another tool in my toolbox, and hopefully interesting YouTube content. And I didn't even realize that Go called those toolpaths a semi-finishing pass, so I think there's room to get an even better finish, even in the Tormach. But I said at the beginning that this method was quicker than I thought. It was, but his finish pass kinda cancels that out. Maybe I'll think about hard milling sideways bevels. I just got my water jet parts back, so I guess I'll take a break from blades and maybe I'll come up with some new ideas. Thanks for watching. Bye.